5.1 and 5.2 are the most difficult because there is a lot of information to remember, such as theorems and properties. Perpendicular bisector and circumcenter. The perpendicular bisector is perpendicular to the segment and bisects it. The perpendicular bisector theorem is if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. The converse is also true. Circumcenter is a point of concurrency of a perpendicular bisector of all segments of a triangle and is equidistant from all three vertices of the triangle. Point D is the circumcenter of triangle ABC. Which segment is congruent to AD? DB and DC are congruent to AD because the circumcenter is equidistant to all three vertices. Angle bisectors and incenters. The angle bisector is a bisector of an angle that can be described as a locus of points in the interior of the angle equidistant from the sides of the angle. This description leads to the following theorems. The angle bisector theorem is if the point is on the bisector of an angle, then it is equidistant from the sides of an angle. The converse is also true. The angle bisectors of a triangle are concurrent and their point of currency is the incenter. The incenter is equidistant from all three sides of a triangle. Point P is the incenter of triangle AEC. Find the measure of angle DAC. Angle DAC is 33 degrees because the angle bisector bisects the angle, making them equal. Medians and centroids. A median of a triangle is a segment with endpoints being the vertex of a triangle and the midpoint of the opposite side. Centroid. The point of currency of the medians of a triangle is called the centroid and is always inside the triangle. The centroid theorem. The medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. In SCU, UJ equals 9, BJ equals 3, and CT equals 18. Phi, JT. JT equals 6 because the distance from the centroid is 1/3 the total length of the median. Altitudes and orthocenters. An altitude of a triangle is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. An altitude can lie in the exterior, interior, or on the side of a triangle. The lines containing the altitudes of the triangle are concurrent, intersecting at a point called the orthocenter. Identify BD as an altitude, median, or perpendicular bisector. BD is a perpendicular bisector, altitude, and a median because D is at the midpoint of CA. It goes to the vertex and it is perpendicular.
Next, we have Chapter 5-3, Inequalities in One Triangle. We chose this topic because it's interesting to learn more about the properties of such a common shape. The first thing to know about inequalities in one triangle is the exterior angle theorem, which states that the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. So in the figure below, the measure of angle 4 is greater than the measures of angle 1 and angle 2. The next concept in this chapter is ordering sides and angles. If one side of a triangle is longer than another, then the longer one is opposite an angle with a larger measure than the shorter one. The converse of this is also true. In the figure below, the angles in order from smallest to largest are 1, 3, and 2. Using the exterior angle inequality theorem, list all of the angles that measure less than angle 9. Angles 6, 7, 3, and 1 all measure less than angle 9. List the angles and sides of the triangle below in order from smallest to largest. The angles in order are C, D, and E, and the sides are DE, CE, and CD. Next, we have indirect proofs. This is the most important concept in Chapter 5 because it allows you to prove things when there wouldn't otherwise be enough information. Before we can start with indirect proofs, you have to know the comparison property of inequality, which states that for any two real numbers, A and B, one of the following must be true. A is less than B, A is equal to B, or A is greater than B. This is useful in making assumptions to start indirect proofs. To actually write an indirect proof, there are 3 steps. Number 1, assume that what you are being asked to prove is false. Do this by assuming that the opposite is true. Number 2, use logical reasoning to show that this assumption contradicts the given or a known fact, such as a definition, theorem, postulate, etc. Number 3, because your assumption is false, what you are asked to prove must be true. Here's an example of an indirect proof. If 2x plus 3 is less than 7, then x is less than 2. Assume that x is greater than or equal to 2. So 2x is greater than or equal to 4 by multiplication. 2x plus 3 is greater than or equal to 7 by addition. This contradicts the given, so x is less than 2 by the comparison property of inequality. State the assumption you would make to start an indirect proof of each statement. If 4x is less than 24, then x is less than 6. Angle A is not a right angle. Assume that x is greater than or equal to 6. Assume angle A is a right angle.